Right, let's post that we're live. Get my lights all in the right place. Completely last minute. And then right, welcome everyone to another stream. Hope we're all having a good day so far. So in today's stream, this is what we're working on. We've got a material system init function that we need to do. We need to create a brick material that we actually upload each frame, so a bunch of material parameters. Last stream we made a let me get my thing up. Lovely. So last stream we had a I guess let's run the game. We can see what we have. So, we have some procedural sky rendering and it updates like every second basically. The sky is moving a bit fast. We also have a nighttime shading now, which looks all right. And we've got a sun and a moon, and we've got these balls here that we're trying to, we've got PBR material shading. So what we're trying to do is do a procedural shading of a brick material, all done in shader code at runtime. That's the plan. I want to see what the performance is like if we cover a whole screen with this brick. What's the performance like? And obviously test to make sure the material shading looks good and works properly. Now, so last stream we got the material system CPU side written up for the most part. We've still got to finish a little bit off. But the basic idea is we've got this global thing called a material cache, and you've just got an array of property words. So a word is just a U32. Where is it? Yeah, it's just a U32. And so when you have a material, it might be an instance of something like the brick material. Here's the encoder file for it. It's just a custom encoding file format. So we can basically define our own properties that will get put into this buffer. And so each U32 worth of data is a word. And so this is one word, it's 8 bits. So we've got brick dims XYZ, the border of the brick, like how big is the border, like the cement, right? Do you have cement? Do you not? What sort of colors do you want for the brick? We've got 2 colors right now. It can alternate between, or maybe do an interpolation. Don't know. And then a border color, right, for the cement, basically, if it has any. And then probably what's the gloss minimax of the bricks, right? And then it'll pick some value in between there. So this allows us to have some procedural shading. So obviously you could have you have a surface. You might say paint brick over there or whatever, and it's a certain type of brick. So this is what's known as a proto material. So it's a prototype of a material. So it means that it's a specification of the material properties and shader code. And so to make a brick material, you basically initialize this structure and you configure the properties, and that will give you a certain brick material. So you might have like a classic like English red kind of brick material, or you could probably do like a more um different a different brick material, perhaps with the same shader maybe. We'll see. Right, you can do, there's all different types of bricks, and maybe you might not want ones which are perfectly rectangular. You might want to have different sort of cutouts maybe. So we'll see. Depends on what we need for the game, right? We can always change the shader. So that'll be pretty cool. So the idea is to maybe get different these proto materials offering quite a bit of flexibility such that the same code mostly runs. So yeah, things to think about. So yeah, today we're going to be getting the initialize function done for the brick system. Create our first brick material. Maybe we do like the red, the classical red ones we see in the UK, right? Just so I can, you know, get something going, and then we'll sort of upload that each frame. We'll write the material system shader code, right? Fit it into the shading pass, and do the brick material shader code specifically. That's right. Yes, the brick system shader code and the brick one. Yep. Cool. If there's any questions, feel free to ask away. But yeah, hope you're all having a good day. Let's just do a quick prayer, I guess. Father, Lord, we thank you for this day. We bless your holy name. Give us the insight, Lord, to write the code that will, for the most part, keep and evolve into what it will be. Help us not be just making stuff that was ultimately throw away. I pray that the system we're building will shall just work and be the one that we keep. And yeah, I pray that you give us insight into just planning things ahead properly and bumping into not bumping into dead ends at all that will cause us to backtrack. But also pray for every viewer here, Lord, if they don't know you yet. I pray that you have they have their eyes opened and see your helping hand throughout their life, how patient you are, and how slow to anger you are, and the good works that you're doing in their life. I pray they see that in the mighty name of Jesus. We pray, Amen. Right, let's go. So initialize function. So we basically got the thing all done last time. I think we forgot to do the serialization bit where we actually save and load it from disk, but that can come once the whole thing's done. It's just going to slow our development down if we get in there and try and write serialization code and have to write a hot reloader as well. Just do that bit last, right? It's just a thing which can get tacked on the end. So there's an init function, and we just got to go and initialize all of these guys, the correct things. Hey, Duke of Cool, this is cool stuff. What about your faith drives you to do this type of work? So I was already doing this sort of work before anyway. You know, I've been programming for like over half my life now. You know, always believe. I think I was, you would call it agnostic, right? Where I always believed there was some probably kind of God, or maybe aliens made us or something like that. You know, I believe that evolution could have possibly been true, but at that point in time. But yeah, I've always thought there was probably some kind of higher power because there were spiritual things that I felt were true. Um, but you know, as time went on, um, you know, I had many encounters where you know I prayed to God basically. I was and I had to help find me a wife basically because there was no no one who wanted to settle down. And then 6 months later, literally just handed on a plate to me as was my wife. You know, just in a way very smoothly. So I've just met her and it just worked out naturally, and it's you know um so God has always provided for me even when I didn't believe. And you know my faith just kept on developing slowly and slowly over time. Lots of things. I got my job through just asking the Lord and things um when I wasn't having any luck before. But so it was more the other way around, right? I was already doing this stuff and now I've decided to dedicate it towards the Lord, basically. um you know um but yeah, it makes you think really how much work this stuff takes, but then the Lord can, you know, he created the world in like 7 days, right? Everything, DNA, right? Everything designed, right? Now, obviously, I don't think he's limited to creating everything in 7 days. I think he done that for a reason. Um, you know, God does everything for a reason. I don't think he's limited to making everything 7 days, but just to see how complex everything is and how well everything works, how creatures and everything adapt to different parts of the world, different climates and things. It's just incredible. But yeah, his studio must be epic. Yeah, yeah, exactly. Well, what's his throne room, right? You know, it's explained in, I think, Revelation 4. Just the pure beauty of it. I think even Isaiah gets a glimpse of it right at the start of Isaiah. Um, maybe it's not described in that one, but yeah, you know, what will be interesting is this, right? So you know, these days you can tell, right? The devil tries to make it such that we try to recreate what is in heaven, but so we can have it as man and be like, look how good we are, right? So look at what's coming next is the brain implant the neural link, right? It's to take away your voice because there's power in your mouth, right? And you'll be able to telepathically communicate with someone and stream in information externally, right? And when you think about it, you'll be incredibly brainwashed at that point. Just think about how brainwashed you get already just by this watching stuff and hearing stuff already, and how deceptive things can be. Just imagine the sheer volume that can come into your brain with a neural link. Anyway, but what's interesting is that when you hear people with like near death experiences, they leave their body and they come back and tell you things which prove that they've left their body and their experiences is probably true if they weren't lying, obviously. Um, they would tell you that they could look at the wall and smell the paint and know exactly what it was, or look at something from miles away and just tell you exactly what that thing is. It's like knowledge just gets streamed into you, and you just find it fascinating that all these advancements that we're coming up to right now in life just stem from what is already promised in the Bible. So there's a glorified body coming. If you're a Christian, you believe that the rapture will come. Jesus Christ will basically call you up. Maybe an angel comes and takes you, whatever it is, but you will basically be taken up to the clouds and be put on immortality in your glorified body. You'll live forever. You won't be able to sin anymore, right? The promise of Daniel 7 will be fulfilled, where all sin will be taken away, and it'd be incredible. Now, look, in look what we're doing today, what robots being built, and the idea is man can make himself his own glorified body. It's just incredible when you think about it. Um, that the devil is just basically trying to make man live forever, you know. And some atheists think you can download your mind into a computer, and you know, because consciousness is just a byproduct of atoms assembled in space. So you can just go into a machine. But anyway, um, yeah, you know, I guess they can try that one first. Cool. Maybe God be glorified in your work. Thank you so much. Yeah, that's the plan, right? So yeah, lots of prayer and things to make sure we get all that right. But yeah, it's gonna be cool. Gonna be lots of fun. What text editor does God use? That's a good question. You know, I think maybe yeah, I don't know. Does he even use an intermediate language? Right? Maybe. Right? You know, does he use virtual machines? Right? Does he find them pointless as well? All questions to ask when we get there. But all we know is, yeah, you probably just use assembly directly, right? Directly in on the bits. These are all questions to ask Jesus when we get there, because after all, he's the best programmer. So who we inspired to be like is our role model. But yeah. in it. Some material pool. Static allocator. Let's get one of them. Capacity, I got that fixed. Ah. Oh, okay, I was just a few letters off. Next one is the why are you complaining? I'm not making my brain computer until we can know what consciousness is. Yeah, that's a good way to say it. Yeah, I'm making my brain computer. Yeah, that's a great way. Yeah, it's concerning because here's the thing about it. It's like if you don't take the brain computer chip, you are the single. You are the cause of bad people who are limiting the evolution of the human race. People look at you funny and twist their heads, and they'll all be telepathically communicating. You won't be able to hear them. Man, straight out of a horror movie. You can see it already. You're stopping the evolution of man. Man has to take evolution into his own hands since he's caused evolution to not be as effective now because the survival of the fittest has now been minimized through the kindness of our hearts. This is what happens, really. If you think about it, if you're going to be a prophet evolutionarist, you would not want any of the weak to survive. Whereas if you're a person from God, in the Bible, every man and woman is made in the image of God. So really, every person is equal, right? Basically, in that sense. So this is why things like Hitler and that come about. They don't believe in God, and there's different value to each person. That's what will happen eventually in the future, right? When man can evolve themselves and change DNA, install computer and brain. People who don't have their DNA manipulated to take away all the diseases are causing us big problems. Oh, sorry, it's my yeah, sometimes it does that. I don't know. I think, you know what? We can blame the LSPs. Can we turn off the LSP? Let's turn off the LSP. Let's work without the LSP. We don't need LSP. Yeah, good old days. Thanks. Yeah, I think I'll turn on when I need it. Maybe that's it. Hey, Psycho, welcome. Did he just program a long Black Mirror episode? Well, you see, God gave everyone free will, but he knew the beginning. Sorry, he knew the end from the beginning, right? So everyone's name, who is saved, is pre-written in the book of life of the Lamb slain from the foundation of the world. So it's pre-written. So God knows if you're going to be saved, and He's fair in terms of He gives everyone a fair opportunity to know God and to believe in Him, basically. So this is just where free will gets you, basically, is this outcome of the Black Mirror episode. And you know what's interesting as well is the devil basically wants to tell you what he's doing, what his plans are. So what he does is he will give people dreams, give people thoughts, give temptations or whatever you want to however you want to phrase it, to make things which show his intentions. And sometimes people are so deep in like the Hollywood thing and in probably in the occult or some other secret society thing, right? Which is where and they will basically again the devil's ideas out there, in society. Um, so Black Mirror is probably just, you know, showing what's going to happen. Property words. There's a fix for that. Materials. Materials. I guess we'll do that. Or the pro materials. Yes, interesting one. We want to figure out that. How would we? We got to figure out how to, do this automatically. Somehow. There we go. So alrighty-o, so we got that one. Nice. Next one is creating a buffer. Love me a GPVK buffer. Let's find you one. This stores all the properties in some prop words buffer ID. Oh, no explicit. Alright, so give it a lovely string name. So material prop words. So the property words would be this guy here times U32 because it's size in bytes. Lovely. 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 Now, we probably want to initialize it to these values regardless. Then the final one is prop count from so yeah, proto materials are basically like a prototype material. So it's basically just a description of a data structure. So here's one here called the brick material, and it's just got a bunch of parameters that you can configure at runtime. And then when you so you can make many different materials from this one proto material, right? We can have like the classical red brick that you see on houses in the UK, like red and sort of brown bricks, or you can maybe have more of the sort of like brown sort of bricks that you see in the sort of old Mesopotamian, as they say it, architecture, maybe those big old brown bricks, um, possibly, and then I don't know what other sort of bricks you'll get, but the idea is to have a variability of different materials you can make from one set of parameters and shader code, and configurable parameters create different materials, and these can also be changed at runtime because it's procedural materials at runtime. Basically, that's the plan. We'll see how this works with like really far camera angles and stuff like that, but because we won't have MIP levels. I have to do some tricks. Hopefully not 2D for loops, and yeah, that would not be good. Possibly combine generating actual final material. Uh, well, I guess you could kind of interpolate between a couple of them. That could be another use case. Yeah, that's true. But typically, we're going to have probably have material layers as well. So maybe you can have like a moss layer and a brick layer, and then like blend the final diffuse and specular, right? So you would run the material shader for the brick and material shader for the moss, and then just do the alpha blend between the two, if you will. Yeah, so that it'll be quite powerful in that way. Obviously, want to see how expensive this gets. Unreal? No, I didn't do Unreal. You don't believe in free will. You believe determinism, right? More compelling. Fair enough. Well, yeah, I don't know, maybe. So, like, God knows how the end is going to be from the beginning, right? So, maybe in a sense, there is some degree of determinism from it. But God is also what's the word? He is capable of interacting. He is sovereign. That's the word. With the system. But yeah. And then we just pop that in there. Okay, I think that's pretty reasonable. So the question is then, how we need to fill in this guy, right? So the properties count from this. Yeah, so we've got these like thing called like a brick.encoder file, and that's in this brick generated. So we should probably have an array of like, hey, here's all the proto materials, and they're just globally listed somewhere, maybe. And then that global list, yeah. So maybe, but then, yeah. So maybe we'll have like something like this, where we say in C type. Is that a thing? Data type. Oh yeah, I don't have the LSP running. My life. No. So we'll probably have an array of some material data types or types. Let's make it short. So the way I think about it is we could have that brick generated.h, so it's just my encoder system. So there's this GV0 material brick data type. Plop that in there. Done. Now from this, there should be a size. Yeah, there's a size parameter. So you take the size, you take off the header, and then start the LSP maybe. Right, so I reckon yes, so we can get this from for array count of GFX VK proto material types, this guy. Then essentially if we do a for loop over all of these proto material counts, we can pop in here this lovely little map, the number of props count. That's not the right sort of name though. Yeah, so it's like British be called prop. I just called it words. All right, hang on a minute. Okay, so that's good. Prop. Lovely. So we want to fill in index being whatever G, GFX, VK parameter or types, index dot size, take away size of the header. So there's a header in this type. So encoder bin header, I think it's called. Yeah, bin header is V0. So that's just in every one of our binary encoded files, it's got one of these at the top. So it's like a magic number, the version and all that, right? Get rid of that. So we see the brick material. It's got one of these headers plus all the bit fields in that, right? So just taking away the header, then getting that size and dividing it by size of E32. And that should be that written out fine. Now what's this complaining about? Okay, we need the hash functions and all that. Okay, so things like a core fnv hash 64. Then it's a, what's the key? ID from, the key would be a 64, isn't it? Yeah, so core key, hang on a minute. Yeah, core key, compare U64, something like that. All right, it's the key hash. Yeah, so now same with the next one. Cool. What's this one complaining about? Oh, and it's the allocator. Amazing. Do you have X11 as a platform layer here? Yeah, so it's targeting Windows for now, but I have a Wayland one. So I was doing Linux before, and what happened is I tried to port it from X11 to Wayland, and then RenderDoc didn't work. So I was like, well, this sucks. So I had a choice. Do I keep supporting Linux and Windows, and then have to basically maintain an X11 and a Wayland windowing thing? Or do I just park Linux for a while, get everything working under Windows, and then when I feel like I'm not messing around with the platform stuff too much anymore, maybe go back to Linux again? Because I do prefer Linux as an environment in lots of ways. But yeah, it's just easier to support one platform at the moment as well. So there's that, you know. Yeah, it was kind of a big mistake going to Wayland. You know, I should have just changed my desktop. But then, you know, that's another thing as well. People who are using it on Linux would be like, hey, it's not working on Wayland. And I'm like, I'm not using Wayland right now. So there's all that stuff as well to manage and things. And, you know, you can't win. Every time it's the year of the Linux desktop, someone messes it up. Maybe it's System D one year, you know, the next time it's Wayland. You know, I thought the other thing was now there was a oh yeah, the move to GNOME 3 or KD5, and it was complete terrible desktop environment because uh GNOME 3 had basically no features, and then Plasma 5 was super crashy. No, X Wayland is very limited as well, especially when I was doing all this multi-window stuff and trying to access global positions and stuff. It's not accessible in X Wayland. The biggest problem with Wayland is you can't get the global. You can't say this window goes in on this screen coordinate, and you can't read where is my window on the screen because security. So yeah, it's a big pain in the butt. And why? Because I don't know. Yeah, we can blame the enemy. What crap's going on there? Maybe pointers? Pointers. We'll make it it's not accessible in Wayland in general though, until very, very recently they've added it to the protocol. When did they add? Because I thought they only added it for pop-up windows. Right, is that true? It's for pop-up windows only, right? Yeah, if you can find the extension, I'd love to see it. What the crap is the problem with this thing? I thought it's a... Oh yeah, of course. Because you've not declared... Yeah, so... This has got to be actually fixed as a number. So that means then... Actually, we can't get it automatically. But yeah, so we have to declare... Count. 1. Uno. Okay. Okay. So I guess we don't need to store a count in here. Nice, that should be it. Cool. Oh, come on. What's your problem? Oh, we need to include the brick. Hang on a minute. That was included. That was included. Oh, no, it's not. Okay. We're not included it yet. So yeah, we probably want to include it up here. GFX, pro materials, brick. Nice. So I think that's the initialization function done now. So we should be able to compile. I need to break my thing up into different compilation units because there's a lot of code, I think, especially when I've got windows.h in there. I was hoping to move away from all that stuff and get that done, but I've not had the time to do it. So I think splitting up compilation units might be the easiest thing to do. Yeah, so that means we need to also include in the C file. Hey, what one got the brick? Generate header. Okay, so hmm. then we can also include that in graphics. Wrong one. Graphics. One. Okay, get that in there. Nice. Ah, there we go. So that all compiles now. So the next thing to do is to actually get the material system code running and poke in there a brick material into the property buffer. Yep. Okay. So in graphics VK, in it. Oh no. Yep. So we'll run the material cache in it. And so that should run. Then the next thing we need to be able to do is make some kind of test material. I guess let's call it test material ID. Okay, so that'll be graphics VK material alloc, something like that. Yeah. So we need some sort of like proto material name hash. Yeah, so we haven't actually filled in those either. So inside the mesh file, there's going to be a proto material name hash and a material name hash in the file. It says 128 bits. And then, yeah, that's not too bad. Maybe. I think that's right. So we need this one to be able to get the pro material index. Oh crap. And this to insert a new name in there. Right. Okay, so we forgot to do those on the initialization step. So in terms of like... Yeah, so I guess we will basically make a new one. But we'll call them the names. And these is what will be hashed up. So we'll just call it like brick. So I guess these could be an enum. Hey, you found it. Man. It's crazy how you click on the link and you get presented with a furry. You know, it's really interesting the GitLab for free desktop. Don't want my eyes to see that, but there we go. This is a new attempt to resolve issues in multi-window applications. Oh, XX zones protocol. Area limited window positions. Okay, I've not seen this. It seems like it's been merged. Oh, in 23? No way. I didn't see this at all when I was doing my Wayland. What Wayland? What thing did it get in the end? Let me find it so I can bring it up. So it's called zones. Wayland extension zones. Alright, let's look at that on here. I wasn't merged till 3 weeks ago. Oh, so that's why I didn't see it. So it's been in there for like 3 years. I guess there's a 3-year trail of stuff, right? So zones. Client-specific zones for explicit placement. Right. Oh, so basically you maybe have your own spaces where you care about your own windows being particularly in certain places, but you can't access other client windows, other application windows maybe? They relate to each other provides. Really? This sounds so basic. Like this. Wow. Yeah, yeah, yeah. Another extension. Amazing. And of course, you've got to do this sort of like zone manager thing and all that, right? All that faff. Yeah, why can't they just do this from the beginning? But anyway, okay. Maybe there's something else I'm not understanding about it because it's just a first look. Oh, there's no compositor support. Oh, okay, yeah, at the bottom. Yeah, none yet, of course. Yeah. Ah, hmm. That would kind of be helpful. So the problem is that it's going to require like compile time stuff to go in, and of course it will because it's a pro material. Okay. Yeah, so I think an enum would be helpful. So if an enum is there, then we could probably make it shared between the CPUs and the GPUs, and that would kind of be nice. And because it's got to be shared between the CPUs and the GPUs, we can't have nice things, and it must be purely done with macros. So here we go. Graphics, VK, proto material, brick, 0, count, 1. And there we go. So share between CPU and GPU now. Isn't that amazing? So I can get rid of this now. So I just get rid of the plural. Mm-hmm. All right. Nice. Lovely. So when we, yeah, it's got that name for the brick. So names now. So what we can do is insert into the hash table. So core hash table find or insert. We want to define our insert for this material, pro material name, this one. So the address of cache index from material name. Now we've got to provide it this hash, so that will be a gfxvk for a material. I guess we can. It's a bit wide, you see, so I want to just do like a vk per material name hash, so name hash. So that one for string c. I guess we do lit. Let's just do c. Let the compiler do that. Yeah, I think it's going to have to. All right, so name hash is new. Then we've got sort of a destination pointer. DST is equal to index. Ta-da! So now we've got that lookup table all good. So that should work. Right, so where was we? So that test material. So now we need to get this name. So what we could do is so yeah, that's interesting. You're taking in a name. Do you ever need to do that though? Because you're always going to be storing a name hash in the file in the mesh files, and whenever you're going to do it in code, you're just going to want to ask from one of the ones in the list. So what will be better is if you just took in some kind of one of these. Yeah, it's not really consistent, but oh well, there's that. Yeah. Okay, looking better. We like to see. Got a lovely little reusable function now. Cool, so going back to that test material. We're just going to try the brick one, so I just put 0 in there. Right, it's just test code. We don't care. Then this is going to be a sort of a material name. So we can just call this one whatever we want. So it's just an instance of that. So material name hash. So I guess let's call this red. It's like a red brick. Then we finally get the material ID out. Then we get the graphics VK material. Just call it M. Just some test code. The basic idea now is we need to upload the properties. So we can get ourselves a super lovely brick. I think I just called it brick material, but there we go. So call it B, I guess. So we've just got to fill this boy in. So it's going to have the... Okay, we've got to fill it in manually, I think. So V0 brick. Material, there's a brick dims set. The object will be B. And the dimensions of the brick. So in terms of like... I think we're doing it in like meters or whatever, right? So how big is your brick per meter? So we could stick, you know, so we could say like 0.1 and it'd be quite high frequency, but it'd be interesting. I think it'd be small. There could be kind of small bricks. So we can just do evenly, well, maybe not evenly 0.1. So 0.1, yeah, and then maybe 0.1, maybe 0.25 on the Z. Yep, that would be interesting. Then like I wanted to make something Wayland, I would simply just shim the X11 ABIs from XCB and remove the server Win32 style. Right. I see. Yeah. Yeah, it's I think you might be able to do with that new extension, it might be make it easier to do something like that. I'm currently in the midst of code generating my own X11 protocol library. Okay, cool. So far, XCV XML parser is half the lines of code the XCB one. Really hyped about adding IOU ring later. Yeah, it's a really cool thing, IOU ring. I love it. I did some stuff with it. It's cool. You can do lots of stuff with it. It's like I think you can draw parallels to the Plan 9 thing, right? Is that right? I don't know Plan 9 too well, but it's got that sort of like command buffer style system call interface. You know, it's super cool. Like you can do so many things through it. It's amazing. Yeah, man. It's a shame Windows is not doing a similar thing. They tried to do something with X11, but I heard someone on my Discord did some tests, and it's not really ended up too good, to be honest. Right, so set some brick dims. Excuse me. Yeah, there's also one more thing. What was it? It was like a brick. I don't know. Border dimensions. Yeah, just want a bit of a border. 0.01 maybe. So it's just a single float. Border dim set. Lovely. Then what else do we have on the brick? So a brick color 1 and 2. So we can just stick it for red right now, or maybe do like a red and a bit of an orange. Yeah, okay, let's do that. And then like a border color, let's do a gray, right? Gloss min and max. Yeah, so let's do set gloss min and max because these are not. So they're kind of rough, right? So I think you want to have probably 0, right? Completely rough. Although we could have a bit of fun and just make it up to 0.5 and see the glossiness vary. But yeah. Now finally B dot. I guess you can do the other ones in here. So B dot brick color. So we're going to be using the packed color. So there's the 8 bits per channel, but we don't do that because we do what do we do? P3. So you know, it's DCI P3 HDR. So we need one of these guys. So we haven't actually done lots of constants for this because yeah, what can I say? We ain't done it. That's why, because it's new and I've not really had to use it. So I think we can just do one of these and manually poke in the values. They go up to around 10 bits. Hang on a minute. 2 bits. Yeah, so they go up to about 10 bits per channel. So that's 1024. So that'd be fun. So let's get a nice sort of like red brick color. This one. We just got to do some fancy conversions. We could probably try, maybe that sort of, this is alright, maybe that sort of a grey as well, maybe. And you're sort of going between those perhaps. So I want one of these guys. So hexadecimal is this value. So the red is like AF. Yeah, so AF in... Ah, gotta use the mouse. Hang on a minute. I'm a programmer. Okay, so in terms of decimal, it's that divided by 255. Right, floating point, we're back. Times by 1024, 3. voila. 500. Now, technically this is sRGB and I'm doing it in P3, but it's just a test material and I don't care. So it's just a rough guess. Right, technically it's a different color space, so it doesn't really work. But there we go. So, oh wait, I've got to get that as hexadecimal. So, 57323D. So, wait, do I? Oh no, that's sorry, color. I don't have to get it as hexadecimal. Color 10, color. I forget my thing now, so it's core shed. RGB. That's the one I'm looking for. So that's how much red, 500 red. 14. Right, 14 is hex. We could probably work that out ourselves already. So 14 is hex, which is 30. Oh no, 20 something in it. Of course. It's just 20. So 20 out of 1,000 is probably not. Sorry, 20 out of 200. You'll kind of 0.1 of 1,000. So you're probably looking at 100. Then 2 for yeah, technically it's just like times by 4, isn't it? Really the value you're looking for here. So it's something like, yeah, so something like that, yeah, it's about times by. This one will be like 80 then. Then this one is 2, so 2 times by 4 is 8. Done. I'll need a bit of alpha as well. So that'll be 4 alpha. Wait, 3 alpha? Yeah. Nice. Right, so the other brick color will be like a gray. So let's just do literal gray. I wonder though, how much gray will we do? We probably want it to be kind of dark, so we could probably sit it around a quarter brightness. So that's 256-ish. I think I'll do. Cool. So the border color, in terms of the sort of the concrete, right, the stuff which goes in between, it will be more of a lighter sort of yeah, maybe you want it to be kind of brown actually for this. But anyway, we'll do a similar color to this, and we'll just stick it like. Can always tweak it later. So it's more brighter, so we could probably say a 512 kind of gray. Just look for that. And the final one would be. Oh, that's it. Good. Lovely. Every time you read about it, it's 5 new things. Amazing. Yeah, it's really cool. Ring, I love it. Like you can unlock mutexes from it for some reason. It just if you wanted to, you know, just chuck a unlock mutex. It would be great if they added the memory map stuff to it though. Just imagine doing mmap deferred and just being able to like chunk them all up and, you know, all sorts of things. Yeah. There's a Futex system call. You can do a Futex wake and a Futex wait. Get that. So if you have a IOU ring where you've made a series of like entries like, hey, read from this file and write to this file. In between those, you can stick a Futex wait. So until your CPU side unlocks the futex, and when it unlocks the futex, then the write can happen. You know, or you can do a wake and wake something up. Yeah, it's incredible. Yeah, it's pretty cool. Right. So now we need to poke this into the material properties buffer, right? Take all these U32 words, which these things ultimately compile into as a bunch of U32s, right? Here they are, right? Just take those and poke them in to a CPU side buffer that then gets uploaded to a GPU side buffer every frame. So that would simply just be, oh crap. Be careful of frame init. You know what? Frame init needs to be deleted and removed. Yeah, okay, we'll just let one out. So we want to do set material store properties. You do your M material. You do your properties. That would be your address of B, and you'll do some sort of property size. Now, is that really fair? I think you just want to do. You know what? Let's just do. Yeah, I got to change things. Hang on a minute. So realistically, that would be. You want to offset. So props equals core pointer add properties, then the size of the encoder header, because they're all going to have that. Then you want to do a minus equals on the property size, the size of the header as well, basically, because they're all going to have that. Right, so all it's doing is basically, yeah, just copying into a CPU side buffer and saying, hey, this range of words has changed. That's all it's doing. So then when we do an update, let's find the frame in it. Frame in it should probably get destroyed. Although, every time we do an upload, we need to store... that's true, actually. Okay. No, frame in it needs to stay. So what we need to do instead is move that... All right, let's put these functions in the right place. So frame... render... a render function. So where we're sticking all this. So this is what does builds the command buffer basically and then submits it. So at some point we're going to want to do stuff with materials. So you probably want them to be uploaded right at the start of the frame. That is true. So before you record anything which will use the materials, you'd like to... Yeah, so I think you'd... somewhere around here. Let's just stick it in. You would like to do some kind of like frame in it and then an upload. So maybe you could just call it update. Oh, no. You do a frame in it and then an upload. So these will probably come. Yeah, maybe we'll stick it in the... And then in between these two lines, you basically do your test material thing. Okay, hang on a minute. For that. So we'll just upload it every frame, no biggie. Means we can also change the values at runtime and hotcode reload and nice. So we want to get ourselves a graphics VK material. So I'll just go graphics material cache get gfxvk test material ID. Lovely. Cool. Now I'll upload into the buffer. And voila. So this code here in the future shall be replaced with something like a, you know, from the CPU side, we've got some meshes, maybe new meshes which are loading in. Yeah, something like that, right? And those have some materials on there. Make sure they're loaded, right? So I guess there's got to be some kind of like bigger sort of mesh processing system here or something like that. And yeah, the upload materials has to happen in between these two things. That's okay. Cool. Now, let's just try and run that. Now, next thing we need to do is actually try and write the shader code. Let's just get onto that. Oh, that's not very nice. Hash table init. 7 what? 786. So, well, 0, aren't we? Capacity is 1. If 0, give you 1, yeah. What's your problem? Assert non-zero. Yeah, why don't you assert your non-zero? Because this handles non-zero. Sorry, it handles 0. So that is not needed. Ew. Why are you complaining? Right, I think the build system needs a kick. Goodbye. Yeah, I got some bugs in the build system. So good old delete the build directory sorts it right out sometimes. Just sweep that under the rug. Okay, what are you complaining about now? Right, so we're doing the material cache get, and it's got a null ID apparently. Did we not set the ID? So but you're here. So does that mean the allocate not do thing? Right, so this means then one of these things failed. Okay. We could hop in the debugger, I guess. So we specifically want to go for the functions at the alloc. Nice. Let's run that. Oh, that's not very nice. How sad. So we didn't allocate, initialize the range allocator. no biggie. Core range. So this is basically like heap allocator, but just ranges rather than putting it in memory, right? So I think we didn't. Yeah, we didn't. Okay, so the capacity is like how many words are we gonna allocate? How many blocks? So the blocks would be based on the number of materials, right? So we allocate a range of property words for materials. And the strategy for the allocator is first fit 01. Is that the one that we want? Always find. Yeah. So it's 01. All searches. Then the higher power of 2 bucket. Yeah. It's cool. So effectively, what we typically do is this 01 strategy is you get the power of 2, you round up to the closest power of 2, and you check all of the sizes that you have available, which are definitely bigger than your allocations. That means you can just take the first one from the list and then use it. The problem is that you won't be able to search the power of 2 bin before and find one which possibly fits yours. You would basically miss finding the best fit. Yes, we have an alternative one which will do the search. So I think we'll just do the O1 for now. So just quick allocations basically. So it's super nice. Upload has been called before all stored properties for this frame. I think I got the assertion logic the wrong way around, classic Boolean logic. We want to say the start must be not equal to that. So frame init will cause it to be set to yop, and then end it will be set to this. I guess this calls time for the debugger, doesn't it? All right, so let's go. So material cache, the way it's looking is it's got this sort of start at the U32 max and a 0. Perfect, right? So same thing. We do a store. Oh, then it crashes. Did I, it's probably a copy paste error in it. No? Right, so the start was equal to U32 max. So assert that start is not equal. That'd be false, then it will fail, right? Yeah, so what we want to try and say basically is if I think it's an or. So if any of them are not equal to U32 max, then pass. Yeah, that's right. Awesome. Okay. Assertion failed. Attempting to store 24 bytes into a space of 20 bytes. So, where have we gone wrong? So that's because there's probably been padding on the structure. Yeah, there's padding of 4 bytes. Bugger. That is a bugger. We can't tell if the padding's there either. Yeah, there's padding. So, ooh. How we can tell if there's padding, actually, is if it is not a... Oh, yeah, it's a bugger anyway, isn't it? So I think we want to say... What we could do is get rid of the safety checks. And that would just be... it would not be the best solution. But there's... Basically, we've got this generated brick structure. And because we've got this bin header, which has some U64s in there, it's like, hey, the alignment is 8 bytes, but the rest are just U32s. And this portion gets uploaded to the GPU, and we use this on the GPU, right? Because we don't have the bin header in there anymore. So technically, it's kind of 4 byte alignment on GPU, but then we don't know when we get the size of this structure that is actually there's a secret padding field on the end, right? Ta-da. So there's that. We could. What does the this thing look like? So it's got a bunch of fields. We could maybe find the final field in the data type. Right. And then add. Hang on a minute. This type info is wrong. That's not very nice. Yeah, these ones are off by 4. Yeah, they did the extra 4 as well. Yeah, 56. Anyway. Yeah, I think the... anyways, the offsets are just wrong, plain. Oh no, they might not be. Yeah, they're kind of wrong. This seems to be taken away by 4, but anyway. So we could have got like the final field in the type basically. And then you like, you know, get the final field in the type. Yeah, I'm just going to get rid of the safety checks because I don't know what to do better about it, to be honest. But it should be fine. So the word counts just comes from the pre-initialized array of proto material words count, which could be fine. So words count times by size of E32, yeah? Okay. Right, so Cool. So we are uploading to the GPU, I think, if we go to the super lovely profiler. I think before the sky shading, you'll find some uploads. So there's a buffer upload here, frame init, buffer upload, another buffer upload. There's two. So I think is running. So you got this draw storage. Well, there's a bunch of buffer uploads here, to be honest. Maybe they were running at the same time as this one, so they're pasted on top of each other, maybe? I don't know. Or maybe they're running at, no, they're running at the same time as these ones are. So all the nodes are on top of each other in the graph, potentially. That's what I imagine is happening. So the best thing we can do now is just test to see if it works. So what we're going to do now is get into the shader side of things. So in the material plan, effectively we want to make some kind of like graphics materials header, and it's just going to have this lovely material shade with some input parameters and a switch statement. And then you write your shader code in there for the proto material, like the brick one, and output some PBR material, but I think we'll call it a shaded material. But yeah. And then we can do the material layer stuff on top later. And the basic idea is from the visibility buffer shade, shader, we shall simply just include this header and call this function. Voila. So that's the plan. So I guess let's just get the basics in there, and then we'll do the specific brick thing. So let's make a new file. Graphics, shaders, and it's just going to go in here. Lovely little header file. New text document, materials, page. It's a plural. There we go. So graphics, materials, stage. Now, we're simply just going to include, or do it if not def, because it's GLSO, you have to do this. Graphics, materials, H. Define. Done. Now, we probably want to include the, hang on a minute. Yeah. So we should probably move the scene shade, all of this PBR stuff, you know, all the GGX, the Schlick, such a great name. We need to move all of this, I think, into the header file, maybe. Yeah, and then that way anything that wants to do material shading simply just uses this header. So we might have, for instance, a different, you know, forward renderer, right, for the transparency layers, right? Or we might do maybe a ray traced thing, right? So you would basically just include that header, right, and reuse the stuff. So include graphics materials. You know, I'll just give you a quick tour of this function. You know, it's doing the classic per pixel thing, and because it's a visibility buff, we unpack the instance in the triangle. We don't really have a proper mesh system, so it's all just placeholdery, but we've poked in some mesh instance, and inside there we do some stuff like, you know, it's just a cube, so we reverse a sphere so we can just get some spheres without doing a whole big old mesh for that. And then we just populate some shading parameters, the view direction, so direction towards the camera from the surface, and the surface position in world space and the surface normal, and then calculate surface color. So this guy has now been moved into the header file. So I could probably call this material shade. And then that would in turn, I don't know, what do you want to call it? Oh yeah, graphics material shade. So yeah, calculate surface color. I guess that comes from, yeah, I don't know. And then material.emissive. The materials here, the sampled material. Excellent. So where are these guys? Yes, the material shade will produce you. Yes, this sampled material gets passed into the shading thing, I think. So, sampled material, that's what we're going to call it. All this is, right, it's not complicated, it's just the PBR properties. So this will happen per pixel. So you'll get a diffuse, specular, emissiveness, gloss, maybe some AO, right? And so we'll call this graphics material shade. It's going to take in some 3D UV. So I don't have to texture map. That's the whole reason why we're doing this. And then, we're going to want to have, what would be really cool is if we didn't have to pass in this material shading buffer descriptor index thing. It'd be cool if that was fixed. So I think we'll wire that in there. We need the prototype material index, properties. Maybe just this, it would be called a material ref. So I think I've already got this in the shared. So it's like a material, GPU, VK GPU, graphics, VK material GPU. Yeah, we've got this thing. This, we can extract a pro material index and where the properties start in the buffer. Yep. So what would be super cool is, so we'll call this guess I'll call this an M. Yeah. Now, let's go and sort out that graphic shared. Yes, we want to include that's right. Ooh. Cool. So inside the shared header file, we do have some predefined descriptor slots for the sort of debug drawing stuff. So it would kind of be nice if we did it for material properties, because that way we wouldn't have to keep passing it into everything. We will have to synchronize on it. And we could probably do the synchronize. Oh, that'd be cool. In the upload, that'd be amazing. So, yeah. So, this is super cool. Yeah, so what we want to do is go to material cache in it and change it out such that we can pass in an explicit descriptor index. Buffer index material properties. We'll give a bit of a better name for that. Material prop words. Then after we upload We could put an explicit barrier in to say it's going to be used everywhere. And then, so we'd never have to synchronize on it again. That would be nice. Maybe. Or we could just sync on it explicitly. Yeah. Yeah, we'll do an explicit sync. So when we do a material shade, so it'd be a sort of like scene shade, I think it's called. Yep. We do need to stick in here an explicit sync. So sync on the buffer, give me g gsvk dot material cache, this buffer. How are we using it? What's read only? And that, yeah. What else are we missing? Oh, the type. Cool. So now we've got the sync code in there. Let's go back into the graphics materials. So where did we find there's the draw render, draw 2D. Yeah, one of these. Yeah, it accesses the buffer, you see. I want one of these, wherever that is defined. This is it. So inside this material, we're just going to put a lovely little constant. We'll call it the material prop words buffer. And that's just going to simply access the buffer descriptor, if you will, in the shader code. There's a lot of macros to this. It's basically just bindless, right? So there's an array of buffers, right, with a specific type of being a buffer of U30, a buffer of like U32 of elements or whatever, right? And it's this unbound array, right? And it's just called like, I don't know, it's some U32 buffers or whatever it's called. And all this is doing is just using that index and getting out that buffer basically. And it's got this sort of type safe wrapped structure so we can pass in the right things to these macros and get error messages basically, so it's not error prone. That's all it's doing. That's all it's doing. So right now we can just use this macro, do an index and get what we want. So we probably want to have a way of basically pulling words out, maybe. So we could pull in the structure and then use the decode functions. I think we can do that. So we could have that brick include graphics pro materials brick generated. So we could pull that out. And so all we're looking at doing basically is feeding prop start index, if you will. So that'd be like a graphics VK, material GPU, prop start index. And it's kind of the wrong name now. Let's sort that out as well. Shared. Prop words. Now, all right, that's really cool. And then we do want our proto material index. So in here we can do the super lovely switch statement, which allows us to, and I guess we could do this, where we do graphics, material, shade, brick. And that just passes in the UV and maybe the props start index, right? Or the words start index, yeah? Then it could be less indentation. Yep. So case graphics VK proto material brick, and all it does is simply return graphics material shade brick, pass in the UV, pass in the word start index, and voila. And all we're doing is reconstructing here. Ah, oh, Perry. How's it going, Perry boy? How you doing, sir? Good to see you. So +0, because I want to do a +0 whenever you can. So we could probably just build this brick material. It's accessible on GPU as well because we code genned it to be that way. We included the code gen header file. We could probably just call this M, right? And we just pray and hope that the GLSL compiler is going to optimize this code. If not, we'll have to code gen something else which works off of a buffer directly. So we're just going to poke into here each field one by one manually, kind of error prone, but here we go. Maybe we can do this stuff better, I don't know. Brick color 0, brick color 1. Border color then bit fill 1. Cool, so it's just basically, +1, +2, +3, +4. So now reconstructed the structure. So now we can extract out the bit fieldy things. So that'll be something like the float 32 times 3, or maybe the vector 3. So that'll be a brick dims. How big is a brick? So that'll be your V0 brick material brick dims. Yep. And then we want to make sure we vector 3 it from a packed vector. Then we also need, oh, it was like a brick. It's just a floating point. It was a border dim. I think so. Lovely. Then the final one is the gloss. Gloss min max. All good. Nice. Glad to hear. Yeah, not doing bad, thank you. Not doing bad, just yeah, just working, going to church, studying the Bible. What else am I doing? Obviously hanging around with family. I got some news coming soon, I think. I'll reveal it in the future, I think. Maybe. Yeah, I'll hold the news back. Ask me next month what the news is, and I'll tell you the news. The can I guess the news? Maybe this is going to be strange territory because I got to try and not lie now and keep a straight face. Yeah. So we could return now a sampled material. I guess you can call this S. So we could just hard code stuff for Neil. So it's not really going to have any specular, isn't that right? No specular. Because it's like, it's dielectric in it. Because, is that right? It's diffuse. Yeah, it's not metal. Right, that's right, yeah. No emissiveness, unless we make some, yeah, unless we do that. Cool, so we can have play with that. No gloss. Lovely. So, Neil, with this, what do we do? Where do we poke this in? So we've got this calculate surface color. So we could have the material GPU pass in along with the UV into the shading structure. And then that could be passed in. Yeah, but then you might have different material layers, you see, right? So there's that. But then you could just have 4 layers here or whatever it is. And then it does it all for you, right? Why should they be separate? Or you could pass in the final sampled material and then have a separate structure that gets filled in. Nah, it's too. Let's just put it all in one. So we're gonna have our sort of a GPU, the graphics VK material GPU. So we'll just call this the material, and we'll have the UV. You guessing 3 will become 4? It's a very good way of putting it. Maybe. Um, um, yes, that will then mean. Maybe Perry. How's the is it your girlfriend or wife? Because you talking about going to like America, weren't you? America. Did you end up like committing yourself over to there in the end? The land of the free. Shading.uv, shading.material, and then you simply just get one of these big old fat structures back. And then you get rid of that. So now it's just a case of filling this guy in. Not yet, visa not sorted. She is over in the UK at the moment and going back in April. Cool, cool. Amazing. You guys married? Getting married? Okay, so shading. UV. Right, so what's the UV going to be? So what's great is we have a sphere, right? And we just literally take the local space of the sphere. Boom. Right, so if we have the ray origin, now what's the way of saying it? You have the hit position right here. So you then just take the center pause. Yeah, surface, position, world space. You then take like the center pause. Yeah, you want to work out the position in local space, if you will. So that'll just be you're going towards the surface position from the center position. And then not asked yet, but that'll be the plan. Amazing. Very cool. Well, yeah. Yeah, so when I did mine, right, so there was like what was funny is my wife was like incredibly impatient at that point in time. She was like, you know, I think like nearly every week would go by and she'd just be like, "We're not married yet," and I'm like, oh. Like, how am I supposed to surprise you if every week that I'm supposed to, always like this? And then so I finally get everything ready, and I got the ring. And I'm like, right, here we go. We're gonna go down to this local park. We're gonna take a nice little walk around. I think it was like, um, it was Valentine's Day, right? And surprisingly enough, it was kind of sunny that day. February and March and April are typically hit and miss when it comes to weather. It was sunny. It was like, great. We'll go down, walk by the park. It'll be a nice scenic sort of route, and then we can come. I can ask her there. So we go round. Turns out there's a bunch of men with like chainsaws chopping down trees and the whole destroying all of the lovely scenery. And I'm like, well, um, yeah, that's kind of ruined it. And then on the way back, my wife at the time, my wife, I guess, she was my girlfriend at the time. She was getting to the point where she was complaining again, like, oh, we're not married yet, right? Again. And I'm like, I'm literally just about to do the deed, just like in my mind, that's what I'm thinking. So we're walking back, and I see this path, like going towards this sort of nice bridge, and there's like light shining down, like you got the god rays coming down on this nice bridge going across this like water. And I'm like, this is the spot. So I go up there, and I'm like, I needed like a delivery vehicle. So I was like, I got some chewing gum box, the extra bubblegum chewing gum, I think like 50 in a pack. Pops the lid off, put it in there, and we get on the bridge, and I'm like, hey, a minute, would you want some chewing gum? So I pop the lid, and then she looks in there. She's like, I'm like, get it out and then do the thing. But it's like, yeah, it's by the grace of God that happened that way, because it was like the perfect spot, and it just came to the right as we was walking back. But yeah, honestly. uh, yeah, but it's good times. Good times. Shading dot material. So we're gonna get the material from. So really the mesh should have the material, so I guess we can just store it in the packed instance for now. And that way we can yeah. Interesting. Hang on a minute. Oh, 2D pack. Perfect. You belong inside. Hang on a minute. Yeah. You belong inside my encoder file. Lovely. Yeah. Yeah, it was yeah. I thought of it as like a bit of a cheap way to deliver, such an expensive item, but it was it's a way to it's the perfect thing to catch her off guard. So I was like, okay, I'll settle this. I can just be like, yeah. The worst thing is if she would say no to the chewing gum. Then it's like, okay, now I just got to pop it open anyway. But yeah, I'd be like, you sure you don't want to take one? And then she looks in. I guess that'll be the way. So putting the material structure in there. So yeah, it won't be in the instance in the future, obviously. It'll probably be per sort of like face. Yeah, so each vertex face or something like that. I don't know, we've got to figure that one out. So for now, goes in here. The goodbye color. Don't need the color anymore. Isn't that lovely? So from the CPU side, we just got to fill in those material. Where is it going to be? Test material. So the test mesh. So they're here, right? So what we need to do is simply poke this guy into here. And we just got to change the this very silly but simple mesh cache, which will be expanded to be much better later on. Material ID. Then we change it to a reference. So material, and then we do our graphics VK material GPU. Yeah, one of these. So you need to do your GPU VK material cache get. Oh, sorry, graphics VK get. Yep. Lovely. It's run the build system, so we regenerate the code gen file. Okay, so why are you complaining? Oh, okay. Yeah, so we'll move the ID out of here, unfortunately. Yeah, about that. So probably this needs to be reordered. Mesh cache will come afterwards. It makes sense after all. So Sorry, yeah. Mesh cache comes after. So realistically, we need to then move the source file above it as well. Okay. Why is this one complaining? Oh yeah, words. Okay, so graphics materials.h. Oh. Why is this complaining? Oh, okay. Right. Yes, it seems like some of the decode stuff. Oh, yeah. So it's got some casting. Well, fix the casting operators because they're not dependent. So we should probably have a cast macro to handle that across CPU and GPU. Anyways, yeah. Right, so nearly there. Yeah, let me take a quick break. I'll be right back. But any questions, guys, feel free to ask away happily. Answer those. We get back. Right, welcome back. So yeah, we've got to do a silly thing. Yeah, in programming, you have to do silly things. It's required. Really added like a casting. Yeah, casting thing. So, you know, there we go. So in GLSL, it's obviously type X, whereas in C, it's like that. Ta-da. Anyway, and then in the code generator, so in C, yeah. So that'll be anytime. Yeah, so it's those sort of like bit filled things. I don't know where we'll search this, so I guess we'll do. Let's just find it somewhere around here. These look like it. No, let's type information. Oh, this looks like it. Yeah, so all these brackets. This is the store function. So let's call it cast good old code gen code. Running more casting is cast here. Hmm. Oh yeah, we should probably change the. You would probably want to wrap that in more brackets. Maybe. Okay. I think that's looking reasonable. And the final one is the bitfields load. So there's just one cast that we saw, I think. I don't know. Yeah, I think that was it. Yeah, that was it. Good. Just regen that. Cool. So these are all complaining now for some reason. Yeah, we've progressed. That's good. Okay, so this one's complaining because there's no PC anymore. Oh no, that's bad. There's no push constants. Hmm. So we could make these sky irradiance images and, the, what else? The reflection BRDF. We could make these more global. Uh, statically known descriptors. We could also just put them in some global structure somewhere. So for sky, they're going to be fixed anyway, right? And I guess if we need to do reflection probes, that's a different system. So potentially we could do the same thing. By making them statically known numbers and stuff. Hmm. Yeah, then it would avoid passing them in, but I guess you would still need to. Yeah. Well, that reflection MIPS is going to have to be a global. Yeah, I think we'll rewire this to be constant. So irradiance, reflection, and reflection BRDF. Okay. Why is it called? That's wrong. How does this whole system work? Right, before I do this, let me... I don't know why we didn't get any errors before. Oh, okay. Anyway, just live with it. So, right, so sky irradiance. Yep. You want sky reflection, and you'd also like BRDF reflection. All as these lovely constant things. Cool. So, sky reflection image, you want this to be an explicit. Graphics VK image index sky reflection. That's not very nice. Yeah, you can't really do those because the MIP levels, I remember now. Yeah, we can't make them explicit. Well, that's not fun. So I guess we'll have to have them passed in as part of the shading params. That's okay. So shading params. No, not that one. Yeah, these guys here, so it'd be kind of that, so it'd be graphics materials, shading. So we just poke these in here. Okay, so the sky image, irradiance, reflection, and the MIPS. Yeah, we'll just fill those in from the scene shade compute shader. So these are just done via the push constants basically. Like so. And then from the material side of things in here, we just get rid of the whole PC kind of thing. Oh, hang on a minute. We replace it with shading dot. Yep. Now get rid of the extra close bracket. Now let's try that out. Oh, here we go. Interesting. It's a bit filled 0. Scene shade 84. Oh, okay. Right, so this one needs to be set to whatever instance.material is. Oh, we're getting close now. This is good. Yeah, so I moved those things around. Now it's complaining. Ten has already been allocated. Oh. Why can I move this around? What was the problem? So initialize GPU. Buffers count. What's the point of this then? Yeah, it sounds like go over all the buffers. Oh, it's the pre-initialized buffers, but then yeah, so we explicitly initialize the global buffer. Doesn't that up the number of buffers? Hmm. Right, buffer ID next. Allocate IC. Yeah, so that should up the number of buffers. Ten is already allocated. Yeah, I'm not sure why we pass in the buffers count then. Doesn't make any sense. I wonder what happens if we passed in 0. What happens there? Right, so it goes to initialize the cache. And 10 would already be allocated. Oh, that's just because with right, I see what's going on. We've got an overlap here, right? No. Oh, I see what's going on. This is because the explicits all need to happen first. So I think we need to move this one out. Yep. Because when we do a buffer in it, it's going to bump allocate and then use the ID which we want to be hard coded. Cool. Right, so we're actually getting the result now. I'm not sure, we're not seeing the specular highlight anymore though, probably because the roughness or the glossiness is 0, something like that. We can change in the shader the gloss and see if that's true. So we make it a gloss of 1. Yeah, you're seeing the specular highlight now. Right, and if we do 0.5, you're going to get a bit of a wider one, yeah? Cool. Nice. So 0 gloss. So that's great. Right, what else could be? Yeah, I wanted to quickly sort out that problem then. So, well, it's not really a problem anymore. So GPU VK spec. We just want to get rid of these things. They're pointless now. Just find all those errors. Yeah, they just weren't used. I'm still confused. Why? Okay, they're not being used. Cool. Right. So now all that's left to do is write the brick shader, basically, right? So effectively, what we could do is just put the brick color in here, right, just to see if it works. So diffuse. Oh. Yeah. So I think what we kind of want to do is have a lovely constant. We'll just call it so, you know, yeah, so we're passing out diffuse and specular, but half the time you only really want to set diffuse or set specular, basically, depending on if it's metal or not metal, right? And you can kind of set both if you wanted to. So I wonder if I wonder if we should just make a function which just sets up maybe a metal and a dielectric function or something like that, or you can manually set them. So yeah, because one's going to set diffuse to black, but you want to have control over both of them and output those properties such that they're separate, right? So, you know, I guess we can do sampled material set color metal. I guess you did that in out thing. So m dot, so for metal, a diffuse is going to be black, whereas specular be whatever color is. And then you have the dielectric. I just spelled it dielectric. That's what it is, right? That's the wrong way of saying it. Is an electrical insulator becomes polarized when exposed to. Maybe that's the or it's a non-dielectric then, isn't it? So you call it, maybe it's call it non-metal. Unlike conductive metals. Okay, so it is dielectric. Good. So I was right. So they have. Okay. No. Right, maybe it's just the wrong word. Let's just call it non-metal for now. So that would then put it in your color go and then your specular 0.04. Alright. So we've got these functions. It's alright. It would do. So we can just do S and then your value. Now that cool. So your color, we could unpack it just from the brick color for now. So I wonder, did we do the core shared? I don't think we've done an unpack 1010. No, I think we have. I think we've done an unpack. Hang on a minute. Yeah, unpack. We've done it. Nice. So you want that basically, and you want to do a m.brick color 0. This should get that red that we put in RGB. Put the color in there. So we try that out. That should just be that nice red color. Yeah? Oh, so now you're complaining. Cool. So the red is appearing. Nice. So that means then we are passing in the values properly. It is coming out a little bit orangey though. Maybe we need a little bit more red. But it could do. So yeah, at least we're able to get some of the properties out of the buffer and they are being uploaded. That's cool. Awesome. So all we've got to do now is, do the rest of effectively work out the color based on brick dims, border, and this gloss thing and set these, right? So it's not too difficult and you could basically floor based on the UV around these brick dims. It's a pretty basic shader, which would be cool. So yeah, I'm getting tired though, and I got work tomorrow. So I think what we'll do is we'll save this for Tuesday's stream. So Tuesday, 7:30 p.m. GMT +1. We'll get the brick shader in. We'll double check our PBR code, make sure the PBR code is perfect, and then we'll maybe get a chance to start another one so we're not just doing brick, right? And see if we can do some other materials. The great thing about the brick one is it's going to be like very simple, but we can obviously try some dirt as well. So we might need some noise. Like where do we get noise? Do we do it procedurally via code, or do we have some textures that we sample from? That sort of stuff. Yeah, maybe a sand, you know, copper, gold, steel, right? Maybe like a moss, maybe. That'd be kind of fun. And then maybe we can eventually do some, when we got these ones in, we can do some like material layers and maybe blend the moss over the brick or something. I don't know. It'd be fun. And then we can test like performance and stuff like this. How good of performance is it, and what sort of shader complexity are we gonna have with some of these procedural materials, basically, right? So this is all stuff to experiment with over the next, I would say, couple of weeks. But yeah, in the meantime, guys, there is a Discord if you want to come and chat, and also if you want to support the channel, you can also join the membership via Ko-Fi and get access to this on your Windows 11 machine. There's some requirements on what it takes to run. But yeah, thank you so much for coming, guys. Appreciate you all, and hope you have a good start to your work week as well. Yeah, that's about it. Have a good night, guys. Appreciate you all, and I'll see you on the future one. Bye-bye. God bless you too, sir. Bye-bye.